Hello everyone. So let's continue where we left off last time. So let's solve little bit easy questions. If a is less than 0, find the GCD of a and 0. So any number divides 0 because, well, you could see it from the definition. You could also see it as well because you don't repeat that number 0 amount of times, so it does divide 0. So we can simply take, if a is less than 0, can simply take the absolute value of a, and that is the biggest divisor anyways of a number, and it also divides 0. So you have that the GCD between a and 0 is equal to the absolute value of a. Okay. Yeah. So let's see question 2. If a divides b, question 3, I guess. If a divides b and b divides c, prove that a divides c. So, well, if a divides b, then you can reach b by a, and similarly, you can reach c by b. So in particular, you've reached a by c. So since a divides b, therefore there exists an R belonging to Z such that a times R is equal to b, and since b divides c, therefore there exists a k inside of Z such that b times k is equal to c. So replace b by AR, and then that means that a divides c. So therefore b times k, which is equal to a times R times k, which is c. So therefore a times R times k is equal to c for sum Rk belonging to Z. Okay, perfect. Yeah, let's move on to the next question. So question 2. Prove that b divides a if and only if minus b divides a. So if b divides a, so that means there exists an R inside of Z such that you can reach A through B by R. So that means that minus B, so minus B times R is minus A, so minus B times minus R is A. So in particular, not in particular, we must have that B minus B divides A. Therefore, minus B divides A. And by analogous reasoning, we get the reverse implication. Argue similarly. I didn't pronounce that correctly. Argue analogously. Analogously. Okay, perfect. Just I want to cover all the problems in the book. All right. Let's see. All right, I'll end the video here, and then we'll solve probably the first chapter's problem in maybe 2 to 3 videos. All right, see you guys.